Okay. So, as I was just saying, I want to cut out some of the fluff here. Get down to some meat and potatoes, as it were. Why do I always end up on the wrong color? All right. That may or may not be the right number for you, but I'm going to call it Magneto Speeds, just for lack of a better heading here. And this is going to be a couple of key points that you might want to know. The number of cam lobes. Number of cam lobes. How many lobes does the cam have? The cam, not the camshaft, the one that you guys have. How many lobes does it have?
2.
It only has 2 because it's really just it's an kind of an oval, if you will. Boy, I blew it. But so we'll say this is like cam lobe 1. I know that looks like it has 3. Huh? So that one has 3. Let's go to PowerPoint. My gosh. All right, there we go. There's 2. So this is kind of lobe 1, and this is sort of lobe 2 down here. And so we only have 2 lobes. So the number of cam lobes, not com lobes, cam lobes, number of cam lobes, that is of the breaker cam, is equal to the number of poles on the rotor. Why, if I were to look at the cam on this one, it sort of looks like that. So how many lobes would you say that has?
4.
So how many poles would you say this rotating magnet has inside of this?
4.
What kind of magnet is this? Dual mag. So that has 4 poles. All right. That's not real hard math to do. So a 2-pole magnet has 2 poles. 4-pole magnet's going to have? 5-pole magnet's going to have? Why would you fall for that? No. I just made that up. North, south, north, west, south. The number of high voltage impulses. High voltage impulses per full revolution of the rotor is equal to, anybody care to guess? Number of poles. So in other words, this one here has got 2 cam lobes, therefore it's got 2 poles. And if I go around 360 degrees, that would be 1 revolution. 1 revolution, so I start here at 0. That's how many degrees?
100, 270, 360.
How many power impulses did I get? 2. So if we do the resultant flux curve, points open right here, open, spark, open, spark. So it's open / spark, and open / spark. So how many sparks do we get out of 360 degrees? 2. Okay. So remember, because you already covered this, 0 degrees, 90, 180, 270, 270, 360. And so you should be able to look at that. I do have some questions about what happens when and where based on degrees. And so if I do ask you something like that, which I will, draw a little curve out and figure it out. So a 2-pole magnet has how many sparks per revolution? 2. Okay. 4-pole would have? 4. 0.3. The number of cylinders number of cylinders that fire per revolution of a crankshaft is equal to, you should be able to fill in the blank here. If I have a 4-cylinder engine and the crankshaft goes around once, how many cylinders fired?
2.
Half of them, yep. To 1/2 the number of cylinders. So a crankshaft has to go around twice to fire all of them. So if it only goes around once, it only fired half of them. In my example, 2. All right. Another way to say that is all cylinders fire in 720 degrees. Why 720? What is that?
2 rotations.
2 rotations. All cylinders fire in 720. Therefore, 1/2 fire in 360 degrees. And this is what I'm not getting into. Therefore, the ratio of the speed of the Magneto to the crankshaft is equal to the number of cylinders divided by twice the number of magnetic poles. Aren't you glad we're not going to cover that? So, I figured you would be. All right. What letter should I be on? Okay. Compensated cam. There's a thing called a compensated cam. Let me see if I have a picture of their compensated cam. Let me see, compensated cam, compensated cam. Do I have one? Do I have one? Do I have one? Kind of crappy, ill-prepared teacher am I?
The best.
All right, no picture of a compensated cam. Well, you know what that means. I have to draw one.
You got Google.
Okay, in these magnetos right here, right, the S20 series, the D2000, 3000 series, these are really designed to go on a horizontally opposed engine. And in a horizontally opposed engine, the cylinders do the same thing, the exact number of degrees apart. So if I were to look at a 4-cylinder and I'd say, okay, I'm in top dead center here, in exactly 360 degrees later, that one's going to be on top dead center. Or if I were to say that in a 4-cylinder engine, all the cylinders are going to fire in how many degrees?
702.
720 degrees. So for all the cylinders are going to fire in 720 degrees. So 720 divided by 4 is 180? 180. So every 180 degrees, something fires. Follow? Okay. Take a radial engine, though, and just by their very nature, the way that the crankshaft runs in sort of an eccentric circle, because of the way the master and link rods run, you can't take a 9-cylinder radial and say, well, you can, this part. So in a 9-cylinder radial engine, all the cylinders are going to fire in how many degrees of rotation?
360.
How many degrees? I got it on camera. In a 9-cylinder radial engine, all the cylinders fire in how many degrees? 720, not 360, 720. It's the same formula. Okay, so who's got their calculator? Nobody.
Each one fires at 80 degrees.
Okay, thank you. So you did 9 divided by 720,
Yeah.
and it should fire every 80 degrees, should fire a cylinder, right?
Yeah.
Thank you. It doesn't work that way. Runs in an eccentric circle. And so they get off. And I don't know exactly how many degrees or which ones, but they don't fire evenly. So there's a missed time between them. And so if I were to make a Magneto that fired in that way, so like this one,
It would be no problem.
yeah, so the cam is, cylinder 1, then 3, then 2, then 4, then 1, then 3, then 2, then 4. It goes back and forth quite evenly, so you only have 2 lobes to fire 4 or 6 cylinders, and it works out. But if I were to try to do this on a radial, one cylinder would fire when it's supposed to, and this would go 80 degrees?
Yeah.
80 degrees later to fire the next one. The next one's saying, hey, where's my spark? Should have sparked by now. Now you're late. And another one's like, well, now you're early over here. And so you'd have some that are early, some that are late, some that are on time. So you can't do that. So you have to have a cam that is designed to work with the radial engine, and therefore that's called a compensated cam. You're hoping you're going to get some sort of money there. So that'd be a compensated cam. So, and it doesn't, it has 9 lobes. So if you have a 9-cylinder radial, it's going to have 9 lobes. And so I had to draw a picture, which I probably shouldn't. So we just draw around one. It's just going to have lobes around it that are not, I lost count. 8, 9. Did I do it right? I have 10? That's 10. So it's got an extra one. Anyway, at some point you'll have a little dot. What's the little dot tell you? Not the master. That was a good guess though, because the master cylinder on some, like on the Lycoming mixed radial, it's number 7. So that's down the side. So, but it's the number 1 cylinder.
Are you covering yourself with your little ticker down the bottom?
I'm okay. Well, maybe about right here I am, so I could just go up just a little bit. There you go. Pooh. Okay. All right. So compensated cam, so the little dot's going to point to the number 1 cylinder. So compensated cam, and what's the reason for that? In radial engines, so it's only going to be found in radial engines because of the way the master and link rods and if you're first semester you're going, how are we supposed to know that? You get to know it next year. Are connected. The path of each rod is elliptical. Path of each rod is elliptical. I think you did. Each piston. Oh yeah, you're right. I did it math just a little bit different. I don't have to go into. I said in a 9-cylinder radial, you would expect each piston to reach top dead center every 40 degrees. That's 360 divided by 9. But some cylinders a little more than 40 and some a little less than 40. So if we used a typical symmetrical cam, the spark would not be correct for each cylinder. To correct for this, a compensated cam is used. I'll just skip to this one. A compensated cam. Compensated cam, where am I here, has the cam lobes why do I have this up? That's just annoying. Has the cam lobes properly spaced with the number 1, that's not hashtag 1, it's number 1 cylinder lobe clearly marked. Now in these magnetos, you got to think this through a little bit. This is driven off of a gear that's driven off of the gear train in the back of the engine. So that has to be thought out how fast this is going to go, and it's by design. So this, and we know that it's going to work out so that the distributor gear is turning how fast in relation to the camshaft.
Half.
Thank you. Same speed as the camshaft. Same speed as the camshaft. What about the rotating magnet? Is it spinning at the same speed as the camshaft?
No.
No. In fact, you know, if it's a 4-cylinder, we can kind of do some simple math. Go, what's that spinning? No, not twice because it's 4. Anyway, whoops, I'm going to make a mistake. But the cam, this cam, the rate, and this is what I skipped over because this is really not that important for you to remember that. Just know that it's different. So this cam here, is it turning at the same speed as the cam shaft of the engine? No, absolutely not. But if I had a Magneto that had a compensated cam, what speed must the compensated cam turn at? There you go. Compensated cam has to go at the same speed as the camshaft. So it can't have a Magneto that's built that way. They're built a little bit different. That's why I said these are more designed for flat engines. So where am I here? I'll write that point. Compensated cam. Compensated cam must then be driven off of the distributor gear. Distributor gear, which turns at 1/2 crank speed. Now, I could possibly put 1/2 crank speed or camshaft speed. Why can I not say that, and why would people be laughing at me if I said that? Come on.
The camshaft doesn't turn 1/2 crank.
Somebody's got to have the answer to this.
There's no camshaft in the radio?
You don't get half.
Hey, how come my first semester guy gets it like that?
Well, because I
You
played in the
second
thing.
semester guys need to be ashamed of yourself. How many camshafts are in a radial engine?
Yeah.
It's disc, isn't it?
You know how there's a radial toy thing?
Yeah?
Like every time I sit there, I spin it. So I'm like, wow.
There is no camshaft in a radial engine. You have what? You have a cam ring. And the cam ring can be driven at a completely different speed than the camshaft because of the way it works in the engine. So you can't correlate the two. So it's got to be driven half the crank speed. All right, distributor speed. Now this is review. You guys freaking out there?
Yep.
Okay, back to talking about these type of magnetos. What is the distributor speed? Come on.
Speed of the cam.
Okay, 1/2 the crank speed or camshaft speed. Because remember, the crank is the muscles, camshaft is the brains. Okay, well, you got that. I'm gonna grab another Magneto here. I think about stories. This is an old Bendix style Magneto, and the cover's off a little bit, but I don't know. You watch old TV or something. What does it kind of look like?
Old camera.
A train?
Old camera, lantern. Second looks like an old. Yes, it does look like an old. Well, a couple of things I can note about this one right away. All right, they call these old lunchbox Magnetos because they look like an old timey lunchbox.
It's like a meat grinder.
And my grandpa had an old lunchbox like this. And I used to, my shop used to overhaul. We were one of the few shops around that would overhaul these old, and they're really great old Bendix Magnetos, and they go on antique aircraft. And what you'd have, these are the towers where the spark comes out. But anyway, there's little marks right here where little stickers would go. So we get these stickers made up, and then we put the stickers on. And the stickers would go next to each one of these towers. And what the stickers would represent would be the firing order of the Magneto. Because it's a little complicated in this one because of the way the distributor is a drum and the way it comes around. And so you'd have one on this side, and then it would come up and it would fire one over on this side, and then it would fire back down here. So holding it this way, you'd have, one down here would fire, then one up here would fire, then one down here, then one there. And I forget exactly which order it is without looking at a book. So you always want to label those. It's not as intuitive as saying, well, if this is number 1, then it's left, that's 2, that's 3, that's 4. These don't come numbered. And what happens with these when you put the harness on, especially nowadays, you buy a new harness and you put it on, you say, well, this is going to go on this type of aircraft, you order it, you put the harness on, it's idiot resistant, it only goes on one way, you take the harness leads, you look at the end, and they're all stamped. It has B1, where does that go? Bottom of number 1 is T1, where does that go? Top of 1, all right, so that's really easy. This one's a little more complicated, and the harnesses are it's not a harness set. They're individual wires that screw on, so they're different. So you mark this right here, and it's the firing order of the Magneto. And so I tell you that to say there is a distinction between the firing order of a Magneto and the firing order of an engine. So if I were to ask, especially all my second semester students, what is the firing order of a 4-cylinder engine, because they're all the same, what is the firing order of an engine?
1, 1, 3, 2, 4.
All right, so firing order. All right, so we'll make that point. Firing order of a 4-cylinder horizontally opposed engine is 1, then 3, then 2, then 4. All right, that's the engine. So if I look at the engine, I look at the data plate, I look at the case, it'll say there, the number 1's going to fire, then the number 3, then the number 2, then the number 4. All right, the firing order. And the reason why I don't do 6 cylinders is because number 1, it's hard to remember. Number 2, they're different between the brands. So firing order of a Magneto is 1, 2, 3, 4, 5, 6, whatever you got. It's in order, which is to say that 1 fires, then what's the next one that fires?
2.
The 2, then the 3, then the 4. It's not the cylinder it's going to, it's just the order of the Magneto. So the way these Magnetos here were built and labeled, you put the stickers on, what was the firing order of the Magneto. So the sticker 1 meant that's the first one that's going to fire. Number 2 meant it would be the second one that would fire. Number 3 would be the third. So inevitably, almost every Magneto we built, until we finally started putting tags on them, we would build them and we'd get a call. Hey, you guys overhauled my Magneto. Let me stop you right there. It runs rough. Yeah, how'd you know? How'd you know? You always build Magnetos? No. You don't know how to hook up you don't know how to hook up an engine. So in the engine, firing orders 1, then 3, then 2, then 4. And the mag is 1, 2, 3, 4. The number 1, first one to fire in the Magneto should go to which cylinder?
1.
And the second one to fire should go to?
3.
And the third one?
2.
Fourth? 4.
So you can get a 2 run.
So the way they would do
2-cylinder.
1 to 1, 2 to 2, 3 to 3, and 4 to 4. So they'd get 2 running just fine. Run a little rough. That's what they always call it. Runs a little rough. Why don't you try swapping 2 and 3 and tell them to call me back and tell how it works? So you tell them, hey, that's the firing order of the Magneto. The firing order of the what? Firing order of the Magneto. It's 1, 2, 3, 4. This reminds me of another story.
If you're flying a plane and you don't know what the Magneto is, shouldn't be worried.
If you're flying a plane and you
Like
don't...
if you have a pilot's license and you don't know what the Magneto is, would you get in the plane with the person?
Yeah.
No, most pilots know. They at least know a little bit about it.
You got your left and your right.
So let me think of another story. We overhauled a long time ago. We overhauled a C85-8. That's kind of a rare engine. C85-12 is not so rare. I'm going to mess up the story because I don't remember quite often. It's been so long. But a C85-12, well, this one, 8 doesn't have a starter. That's the big difference. And the Magnetos turn the opposite way. And then the 12. So let's just say, because I don't remember offhand, let's just say this one had, and I think it's actually, I'm doing it backwards here. I believe the C85 has right hand -12 and the 8 has left hand. And so that means that, what is the firing order of this engine?
1, 2, 3, 4.
No, firing order of the engine.
That's
1, 3, 2, 4. Doesn't matter at which one it is. All right, but let's take a look at the distributor.
Just the right or the left?
Okay, so if we have a left-hand engine, and we'll say this is 1, which one's 2? This one or that one? Here?
Yeah.
2, what is this?
3.
3, what is this?
4.
4, okay. If we have a right hand, this is 1, this is
4.
3,
2.
okay. So somebody ordered a harness, and they got the harness because this engine's so common. They ended up getting the harness for this one. So we'll say that was the right hand, just for the sake of my story and simplicity. So 1 goes to what?
1.
2 goes to
3,
3 goes to
2.
4 goes to
4.
that got messy. Okay. But if we order the wrong harness and we got the left hand one, 1 goes to
1.
2 goes to
3.
3 goes to
2.
1, 3, 2, 4 goes to 4. That did get a little messy. Let's try it this way. Oops. Put that back. Hey, all right. Let's try it on this one. Let's see if we can do it right. So, assuming then this was left hand, we'll do blue and left hand on this one so we can follow the wires. 1 goes to
1.
okay, so that worked out just fine. No problems whatsoever. And then we would think this one's 2 now. This one goes to,
3.
oh, that got messed up. This one is
2 goes to 2.
1, 3, goes to 2. Is that right?
Yeah, that's right.
Yeah.
Okay, no problems. And this one goes to,
4, 4.
so how many cylinders do I have running correctly?
2.
2.
50%.
I hate to admit this, but I think the guy actually, I don't know if we sent the engine out or whatever. I remember the guy calling up and saying, it just doesn't produce as much power as I thought it would produce. It flies nice, and it's really not as smooth as I thought, and it's just not quite as much power as I thought I would have.
50% less power.
That's your problem, you thought.
It's what he was saying, and I think we'd shipped the engine out and somebody else put it on or something. Anyway, but we said, well, come on in. And I remember we had a bunch of mechanics went through the engine. It's like, well, do a compression test. No, compression test is fine. Well, it must be the timing. Readjust the time. No, timing's fine. Magneto. It's got to be a carb problem. Troubleshoot, take it off, take it apart. No, carburetor's fine. And I think we went to like 2 or 3 mechanics, and I thought about it. I thought, wait a minute. There's a difference between the 8 and the 12. I bet the harness is backwards. And I said, hey, I bet the harness is backwards. He said, hey, I bet you've been drinking. I said, no, really, I think it would be. Like, it would never work. It would never fly that way. I'm like, I would think so too, but that's exactly what it ended up being. Swapped 2 leads, and man, that thing ran great. Shocking. But this is why you have to know this stuff, because sometimes you're troubleshooting the weirdest things. And you just, now, I'm not taking the credit for it. I mean, a bunch of other mechanics did everything else, and it was down to me, like, okay, it's not any of that. What's left? What could cause a loss of power? I don't know how it came to me, but it just kind of did. So anyway, that's it. All right, firing orders always 1, 2, 3, 4, 5, 6, whatever. Let's see, make this point here. I don't know where I'm at here. I guess here, 2, after my story. The number 1 spark plug wire is almost always clearly labeled, clearly marked. Because of that specific story, when I built engines, when I finally was the guy building the engines, and I would build them up on a stand, including the magnetos, the harness, everything. I would have it all completely done in the build-up room. I always had a point of the magneto would be on the engine, because I build them vertically, and I would put the harness on, and I knew which one was number 1, and I would grab it and look at the end and say, okay, verified, check, number 1, and I would put it on number 1. And then I would look at it and go, okay, it's a left-hand mag, so that's the next one to fire. That's got to go to the, what cylinder? 3. I would grab it and look at it and verify. Yes, it says number 3. And I would put it on number 3. Rather than what a lot of people do is just grab it and go 1, 3, 2, 4, hope it works. But since that day, and now many years had followed, I always traced out every single wire and double checked every single harness. And I think I might have found 1 or 2 wrong during that period of time where the manufacturer had actually put the wrong one in or labeled it wrong or something. So it paid off. So the number 1 spark plug wire is almost always clearly marked. Where am I going to go? Yep. And then most of them these days are all marked, but the number 1 position, like on a slick, it tells you right on the cap which one's number 1. So from there, you just have to do your job. All right, technically, any position can be number 1 as long as the magneto is wired correctly to the cylinder, but don't do that. And what I mean by that is, and I'm going to show you a little bit, when you go to time and put one of these on a magneto, you've got to tell this what the engine's doing. And I'll write this down for you, but it's a simple process. You put the engine where the number 1 cylinder is supposed to fire. Move the prop and get it right there. That's where that engine should fire. In that exact spot, number 1 should spark. Okay? Then you leave it alone. Then you put this exactly where number 1 should also spark. And you put the 2 together. So if this was ready to spark and that's ready to spark, they're correct. Yep. Okay. And then the number 1 is clearly marked. You go to number 1. What I mean is technically you could set it up so anything on here is number 1 as long as you knew what but don't. So I probably shouldn't say that. You'll do something weird. All right. And safety gap. Your book does talk about a safety gap. And of all the magnetos I've overhauled and worked on, I've never identified the safety gap. I believe the safety gap is something that was used in much older radial engine type magnetos, the best of my knowledge, because I cannot identify one. So, some magnetos incorporate an internal gap. I'm going to stop right there. Just talk a little about what's going on. I take a magneto, as many of you will, and given any A&P student have a magneto laying around, what is our tendency to do? Let's just spin that. Let's just have some fun with it. Just snap it a couple times. I got my D3000 over here with an impulse coupling, so I can really have some fun with that. You know, I can snap that thing. Well, what I'm doing is, am I creating a spark? Yeah. So I'm creating, 20,000 volts? Or we can back up a little bit and say, what was the voltage output of the secondary dependent upon? The gap. What's my gap here? I don't have a gap. I mean, it's infinity. So how much voltage am I going to build up in the secondaries? As much as I can. All of it. All of it. So I'm going to build up, let's say the maximum I can build up in this is 20,000. It's going to build up all 20,000 looking for a spot to discharge. And is it really finding one?
No.
Put your finger in here. No?
I did that yesterday.
You did that yesterday? So you know it's not
I'm
going
not
to kill
so
you.
stupid.
Okay, it's shock some sense into you? Okay.
Just get it on camera.
I know. We could simulate. Come on, simulate. I'll only snap it a little. Okay, so every time I'm doing that, I'm creating 20,000 volts. And where's that 20,000 volts going?
Straight to my finger.
It's got nowhere to, it's not going where it's supposed to go. It's supposed to go out through a wire to a spark plug and work its way back around to ground, but it's not. It's just finding a spot in here where it shouldn't be going. It might be going from one of the springs to the side of the tower. It might be sparking inside off of the high tension lead to something bad. But what I'm doing is I am breaking it, basically. I'm doing damage to that, so to speak, because I'm not allowing the spark to go where it should. I could eventually create little carbon tracks or something where the sparks are going across a spot that once the magneto is put in service, rather than going to the spark plug, I've created a spot in here where it says, you know what, that's an easier place to go. I'm just going to go that way. So I think about that. So if the magneto is running, and as we go up into altitude, it's really depending a lot upon the air in here for insulation. What's the air at altitude going to do? Get thinner, so I have less insulation. So there's more chance of sparks wanting to go somewhere else. We call that flashover, going to the wrong spot. And the more I wanted to sit here and do this on the ground, the more I'm going to do damage to it, the more I'm likely to create some sort of breakdown. This is going to create a secondary path. So that's a very bad thing to happen. So if a magneto incorporates a safety gap, the safety gap in there gives it a place to spark to safely internally. So I guess it allows, what can I say, the purpose of an internal gap, safety gap, is to allow mechanics to sit here and spin stuff on the bench and not cause damage.
A secondary gap that's bigger than the gap in the spark plug?
Yeah, yeah. So some magnetos incorporate an internal gap that would give the secondary an alternate method to discharge the spark in the event of an open at the spark plug.
Is this where it was kind of going with the pressurized magneto?
What's that?
Is this where it was kind of going with the pressurized magneto? Or is this
Not necessarily, no. No, I don't think the two necessarily went hand in hand. So I'm not going to write this one, but it's bad for the magneto to operate without plugs or wires, or at least a path to ground from the secondary. So that's safety gap. Since your Q&A still covers safety gap, there you go. Coming in speed. What?
Did you say you've seen it in a book for a magneto, but you've never been able to find it? Or
Correct. I've never physically worked on a magneto that had one.
Oh, okay.
Or at the time that I was building, I've never quite noticed it. I did a couple of old radial type, but not very many of them. Coming in speed. Coming in speed. The speed at which a magneto will consistently fire all leads at a specified gap. This is the speed at which, scroll up a little bit, which a magneto will consistently fire all leads at a specified gap. That reminds me of a story that I probably already told you. Want to hear it again?
Why, surely.
I figured you would be the first to comment. All right, so
You guessed correctly.
I worked for a repair station, and a repair station's cool because FAA is like repair stations, and they want you to be a repair station. If you have a repair station, it's like the company has an A&P, although ironically the A&P is more restrictive than the one you carry. But anyway, if you have a repair station, it means that the FAA does a lot of site visits. They have more control over your quality, and that's why they like it, because it's just a way to make aviation safer. So we did have an overhaul shop for engines and magnetos and carburetors. And so I remember we had a site inspection with the FAA, and like I've mentioned many times, I got along quite well with the FAA, and they like to joke around with us. That's where they had their little, anyway, so I had, my Magneto guy was overhauling magnetos, and it just so happened he had finished one, and we put it on the Magneto test stand, and we're testing it. Now the book says that you must test it, and it must fire consistently at what speed? By 150 or less, must fire consistently across all gaps. So here we have a machine. It's bigger than the one we have, but very similar. So a couple of things. One, you've got a gap. That gap must be set and calibrated. The FA. How do you calibrate that gap? Well, how do you calibrate that gap?
Whatever the book says.
No, the book clearly says just 7 millimeter. So how do you calibrate it?
Probably with a calibrated.
A what?
Probably a calibrated tool.
Okay, how about a drill bit? Just get a drill bit the right size. Well, how do you know the drill bit's calibrated? This is with the FA. Well, how do you know the drill bit's calibrated?
Set on the box.
Micrometer.
Micrometer. How do you know the micrometer's calibrated?
Calibrated.
Calibrated every year, has a sticker on it. What do they say? All right, fine. Let's run it up. Hey, look at that tack. How do you know that tack's calibrated? I'm glad you asked, because not just a couple of weeks ago, the Magneto and I guys sat around and thought, hey, our tachometer's not calibrated. We need to calibrate it. So what did we do? They have handheld tack checkers, right? And what the handheld tack checker, you run up an engine and you hold it near the prop, and based on the flashes of the prop going by, it picks up that with a photodiode, and it will tell you the exact RPM. So we did that, and it took us a while to figure out how to do it and set up a DC flashlight. You can't use AC because it's flickering. And we figured it out. We made this calibration card. We had it all typed up. Said at this speed equals that, all done. And FA thought, hey, that's very impressive. How'd you calibrate the handheld tack checker? I'm glad you asked. It says right in the little box to hold it up to a fluorescent light, and it flickers, and at two blade, I think it's I forget what the number was, 360 or something like that. And so you hold 360, 180. So yeah, 180 RPM, I believe it is. So 180 RPM. Cool. How'd you calibrate the light? Come on, man. That's Division of Weights and Measures responsibility. And they laughed. Okay. But anyway, but it all has to be calibrated. And they weren't joking about that, though. Everything had to be calibrated. And they asked, what is the chain of calibration? They need to know that, and they're going to go through that. So anytime you're working on something and you return it to service, and it tells you you've got to test it to a certain level, you've got to test it with calibrated known equipment. You can't just make up something and hope that it works. Like, I ran it on the bench out at City College, and it had a little light on it and some sort of thing. So I'm sure it was good.
The oscilloscope worked fine, so I figured.
Yeah. Specified gap. It is different. It is different for each mag, but Bendix is, let's say, about 150 RPM. So it must consistently fire by the time it gets to 150. What if it consistently fires really well at 50? Well, then it works too well and you have to break it, right? No, that's good. That's bragging rights. And slick is about 250 RPM. That's the Magneto, not the engine. Let's see. Oh, redundancy. Magneto firing order is what?
1, 2, 3, 4. 5, 5, 6, 7, 8.
Okay. Magneto cooling. Magnetos get hot, and they need to be cooled down. And the way that's done is with blast tubes. And a blast tube, oh boy, I don't know, I can't draw this one. Inside the engine cowling, when it's on, you have the engine. The engine has baffling of itself that seals the engine up against, and then there's another plate in the back that's going to go right in the back of the engine that seals up against the cowling. And then the magnetos are going to go to the back of the engine and mount back here. And what they'll do is they'll put a hole here with a tube that'll just come down and blast. So when the air comes in the cowling, oops, we'll finish the cowling off. When the air comes in the cowling, it goes on top of the engine and down through the cylinders and cools the air-cooled cylinders, but also comes through the blast tube and blasts against the magneto and just kind of swirls around and out the bottom of the cowling. So blast tubes are what used to cool the magnetos. And I guess we have enough time for one more point here. Yep. 4. Dual magnetos. The dual magneto. That is the Bendix D2000 and D3000. That is this one right here. And which one is no longer used on aircraft? The D2000, because they're made out of magnesium and the rotor froze up, and that doesn't work well. They share a common.
Is the magnesium flammable as well?
When it burns, it's super bright. I don't want to say it's flammable, but when you light it, it burns. So I guess that makes it flammable. Share a common rotor and cam.
It's also highly reactive to see someone, right? For the adversity.
But have their own pole shoes. Coils. I could just say primary and secondary circuit. So let's go the pole shoes, primary and secondary circuits. Oops, I'm down in the no right zone, sorry. Primary and secondary circuits. Which is to say, it's got its own primary circuit, it must have its own coil core, condenser, contacts. If it's got its own secondary, it must have its own secondary coil, carbon brush, rotor, distributor finger, distributor, high tension leads,
Everything except rotor and cam.
rotor cam, and impulse coupling if you want. All right, don't go away mad, just go away.